Welcome everyone for this webinar on SatSure Cygnus, all-weather optical virtual constellation. I am Pradeep Basu, your host for today, and we'll be presenting about how this new service of SatSure Cygnus is revolutionary in terms of crop monitoring. Quickly about SatSure. So we are a very young company. We started 4 years back in December 2016 and are having 4 offices across the globe. The primary office being in Switzerland and in India, while we have London and Sydney. At SatSure, we have one goal and mission to help provide decision intelligence from space for BFSI and infrastructure companies to help them manage their asset life cycle and the risk across this life cycle by using space as a primary input and fusing it with data sets which are alternate coming from public data sources, business data, etc. In our 4 years of being operational, we have introduced several different products, of which our SatSure Sparta, and we service our customers through both platform and product enterprise SaaS offerings, such as for agriculture banking and insurance, SatSure Skies for infrastructure banking and insurance, SatCollect, which is our mobile application meant for loan recovery management, and our new service SatSure Cygnus, about which we'll be discussing today. Today's speakers would be as follows: myself, CEO and co-founder of SatSure, along with my co-founder and CTO, Mr. Rashmit Singh Sukhmani, Sanjuta Indrajit, who is the team lead on data science and the developer of SatSure Cygnus, and Sarvesh Kurne, who is the VP of SatSure and heads SatSure Sparta program. The agenda for today's webinar is as follows. We'll be describing about what is Cygnus, what does it offer, the innovation that we have done, which will be followed by a live demonstration by Sarvesh about different comparative analysis and how to access the data. And finally, we'll have a 30 minutes questions and answers session with the audience. Before I hand over the presentation to Ms. Sanjuta, I would like to apprise our audience of basics of satellite remote sensing. While there are different types of remote sensing done, radar, hyperspectral, etc., but the most commercially known types of remote sensing are optical and multispectral remote sensing and synthetic aperture radar based remote sensing. So these are starkly different. Optical remote sensing is a passive kind of remote sensing, whereas synthetic aperture radar is an active kind of remote sensing. So in layman terms, they operate in different parts of the electromagnetic spectrum. The optical and multispectral, operating in the visible and the infrared parts of the electromagnetic spectrum, which is essentially the shorter wavelengths. Well, the longer wavelengths, which is the microwave, is where the synthetic aperture radar satellites operate. Now, traditionally, the literature of vegetation monitoring has been primarily driven through optical satellites. However, synthetic aperture radar satellites have gained a lot of prominence in the last few years, more specifically because of European Space Agency's open data program of Copernicus, which provides free data service, both optical and multispectral data services of Sentinel-2A and 2B, and the two polarization bands, free data, VV and VH, by Sentinel-1A and 1B. So with this background, I would like to hand over the presentation to Ms. Sanjuta Indrajit, who would be explaining about what SatSure Cygnus is and what are the problems that we are attempting to solve for the industry and how it works and how we have tested and validated these solutions. Over to you, Sanjuta.
Hi all, I'm Sanjuta Indrajit, Data Science Team Lead at SatSure, and today I'll be talking about SatSure Cygnus, and the need for an all-weather high revisit optical data monitoring capability. So as Pradeep had already mentioned about all our products, most of them are centered around vegetation monitoring using optical satellite data. And for this, we use a variety of satellite data starting from Sentinel-2, which is or Landsat-8, etc. And here, for the purposes of this discussion, we'll be talking more majorly about Sentinel-2 data. And it comes with its own set of problems. Number one, weather conditions. Optical satellite data are heavily affected by cloud cover during the monsoon seasons, which leads to the limited availability of the data during a 2 to 3 month period. And also second is the longer revisit time. Sentinel-2 has about 5 to 6 days of revisit time, during the course of which we'll not be able to get any data. Where there exist other satellite data which are in the optical domain, they too face similar kind of issues. So we have an alternative to this, which is the synthetic aperture radar data, which can be used for a wide variety of vegetation monitoring applications and crop classification. But it has its own disadvantages. One, it has 4 polarizations, BV, VH, HH, and HV bands, out of which only the BV and VH bands are freely available. Second, there is a dearth of research and industry adoption of such applications because of the complexity of interpreting the SAR data. So there comes in SatSure Cygnus, a high revisit, all-weather optical virtual constellation, especially for the vegetation monitoring purposes. High revisit of about 5 days. Second, all-weather, which skips over all the cloud cover issues. Optical, meaning the final data would be in the optical domain. Virtual, meaning there is no need for satellite infrastructure to be deployed. So what does SatSure Cygnus offer in the first phase of the launch? Number one, synthetic Earth observation data, where we provide NIR RGB bands of the Sentinel-2, which has been taken from the features of the Sentinel-1 SAR data, using a complex deep learning model that we have developed. And the resulting data can be used for vegetation monitoring applications like crop growth, stage monitoring, crop identification, yield estimates, etc. So for this, the reconstruction methodology that we have used is pretty complex and can be simply summed up as a translator. So we have the Sentinel-1 data, which is in the SAR domain, and the Sentinel-2 data, which is in the optical domain. So the model here acts as a translator between these two domains, hence leading to the resulting data, which is in the domain of the optical Sentinel-2 data. So during the periods of cloud cover, the Sentinel-1 data, which is weather agnostic, will provide a gap filling mechanism. So having discussed briefly about the methodology itself, we would like to say that we have done extensive testing and validation on the model itself and the results that we have obtained from it. So for this purpose of demonstration, we have selected the district of Nizamabad in Telangana. So what kind of validation and testing have we done? Both spatial and temporal integrity of the data have been tested, and this has been done on the non-cloudy pixels of the data. So we can be sure that in the cloudy regions, the reconstruction is proper. So this has been done during the monsoon to the winter season of 2020. So that starts from August till December. So this has been done also for a variety of cloud cover percentages. So visually, when we see this data, we can see for the date of 19th of December, the cloud cover has been removed in the reconstructed data. So how does this translate into numbers? So we have set a 5% error band in which we check how many percentage of pixels in the blue, green, red, NIR bands of the Sentinel-2 have been properly reconstructed. Here, a trend is observed that 80 to 85% of the pixels are properly reconstructed. Whereas the normalized difference vegetation index, which is also constructed using the NIR and R bands of the Sentinel-2 data, has also been reconstructed using the reconstructed data, in which we observe that the Ndvi is 99% of the pixels are properly reconstructed. Similar results have been observed on other dates where the cloud cover percentage is even higher. Here again, we observe the trend that 80 to 85% of the pixels in each band are properly reconstructed, whereas in Ndvi there is a 96% proper reconstruction. Since we have here established that the reconstruction of the cloudy images is proper, which is spatial integrity is properly maintained. Here we can see that a cloud cover of 70 to 80% is properly reconstructed, and we can see that the crop regions are properly captured along with the water features also. And on the date of 29th of November, we can also observe that the different features of terrains are also properly captured along with the cloudy data reconstruction. So having established the spatial integrity, we'll now move on to the temporal integrity. Here we have taken the use case of crop classification where the Ndvi trend over a few days is observed, and this is also done using the reconstructed data. So we see that the monsoon and the winter season estimates are nearly as much as the government estimates provided, but the data that we have provided is based on the reconstructed data. And the paddy is a major crop, but the similar trends are also observed in minor crops like pulses. And also we see that from the time between November to December, we see the growth of the crop is also proper. And again, here the government estimates match with ours. So having established the superiority of our results and that our model works, I would like to reiterate the fact that SatSure Cygnus is a high revisit all-weather optical virtual constellation meant for especially vegetation monitoring purposes. And we have filed a patent for the deep learning method that we have used for the reconstruction model. Our results have been peer-reviewed and validated by industry experts, where here in phase 1, we are only reconstructing the 4 bands of the optical data from Sentinel-1, which is the NIR RGB bands. In phase 2, we will be reconstructing the SWIR band also, along with increasing the revisit of the optical data for within 5 days. So with this, I would like to end and also move on to the demonstration by Sarvesh of how to visualize the SatSure Cygnus data on SatSure Sparta.
Major components of Data Explorer, geospatial data visualization tool, Image Explorer, a tool for developers to ingest SatSure Sparta datasets on their application, and blogs and forums where users can access articles, use queries, and collaborate on projects. Let us now have a look at Data Explorer. Currently, we have more than 200 districts in India uploaded on the platform for 3 years, starting from 2019 monsoon season. There are diverse data sets right now on the platform. Vegetation category has crop agnostic and crop specific data sets for the entire cropping cycle. Water category has surface water and an upcoming groundwater data. There is land category and there is climate category, which has NO2, SO2, and CO2 data already on the platform. Let us access SatSure Cygnus dataset. The process is very simple. Step 1 is selecting the region of interest. Step 2 is selecting the dataset category. Step 3 is selecting the date range. Step 4 is clicking search and selecting the relevant dataset in the results. You can see the time series dataset, the relevant data chart available right on the plan. What we are looking at here are scaled Ndvi values for from August to December 2020. As you can see, on 21st of August, there was 100% cloud cover. On 1st of September, there was a 90% cover. Whenever there is more than 50% cloud cover, there's a SatSure Cygnus pop-up which comes. All you have to do is click on this pop-up. There'll be pre-filled data. You have to click on submit, and team will get in touch with you to understand your requirements. Now getting back to the data, 21st of August to 1st of September had 90 to 100% of cloud cover. 29th of August is SatSure Cygnus reconstructed. As you can see, the data set is clearly available even with heavy cloud cover regions. We have managed to bring the cloud cover from 78% to 2%, as you can see. Monsoon seasons are heavy cloud cover seasons in India, and SatSure Cygnus can have the ability to provide insights even in such scenarios for you. To show you a comparison of SatSure Cygnus and a normal image, let us click on SatSure Cygnus. It takes us to SatSure Cygnus demo page. Select a region here. On the left hand side, we have Cygnus Ndvi, and on the right hand side, we have normal cloud. As we move the comparison slider, we can clearly see how beautifully the image has been reconstructed. The data being available at a 10-meter resolution, we can actually zoom in and visualize the extent to which the reconstruction has been captured. The data we are looking at is 29th of August. Let us look at some other data. In this image, as you can see, the cloud cover is pretty low, but even in this scenario, we are able to capture a beautiful reconstruction through SatSure Cygnus. As you can clearly see, we are trying to make access to reliable data even in cloudy seasons, easier for the industry here. So SatSure Cygnus. To book a demo, all you have to do is scroll down on the platform, select the date, select the time, confirm, fill in the details, and schedule an event, and we will get in touch with you. Hello. Welcome to SatSure Sparta. Well, thank you, there, Sarvesh and Sanjuta. With this, we come to the end of our live demonstration of SatSure Cygnus. I would like to reiterate that SatSure Cygnus, where we have enabled the reconstruction of synthetic aperture radar data into optical and multispectral data, could be hugely disruptive, especially from a crop insurance perspective, where claims due to events, localized events more specifically, such as heavy rainfall, flash floods, are usually come with the issues of heavy cloud cover, and it is very difficult to establish what was the actual crop stage or how much is the crop damage. Beyond insurance as well, there is a lot of application from public sector perspective for agriculture advising. There is a lot of applications for agriculture inputs companies, and we see SatSure Sparta as a service that can really change the way satellite remote sensing is used today globally for agriculture monitoring purposes. With this, we would like to thank all our attendees, and I already see that there are questions which are coming, which my colleagues Rashmit Singh Sukhmani and Sanjuta would be taking. I would also like to extend our heartfelt thanks to marketing partners, namely Geospatial Awareness Hub and SpaceFed, for promoting SatSure Cygnus. And with this, would like to open the floor for questions. Thank you again on behalf of Team SatSure. Okay, so if we go into the question answer section, we'll take the first question, which is, what is the temporal accuracy and integrity of the reconstructed data? This is by Jatin Pandya. May I request my colleague Rashmit Singh Sukhmani?
Yeah, thanks, Pradeep. The temporal accuracy for the constructed data, as in when we plotted the profile as such, what we did was we did identify certain features when it comes to the built-up area, vegetation, agriculture area, water bodies, and we compared those profiles with the actual optical data that we get from the satellite. When I say satellite, it's more of a Sentinel-2 data. And we plotted those profile and we checked whether are we able to capture those differences in the profile that usually any feature gives when you plot any time series data.
Thanks, Rashmit. So we'll move to the next question, which is by Mr. Abhishek Narayan. How did you overcome the distortions inherent with the SAR-like large layover and shadow? Rashmit?
Generally, what we like before feeding any SAR data, there's some kind of pre-processing that goes behind during spectral filtering that we have to do and convert that data into DN values. That's our input data that goes into our model. So in that large layers, it's and the shadow are being trained when we feed that model. When we feed the model with the training data. So when I say training data, the corresponding optical image as well as the corresponding your SAR data. So those problems and the issues are somewhat tackled, but not completely, I would say, especially the shadow part. So that's where that rectification will be doing in our phase 2. Right now, we are completely able to remove the cloud cover. When I say completely, around 98 to 99% of the cloud cover is being removed and reconstructed with the actual data. But the shadow part will be taking it in the second phase.
The next question is from Puneet Shankar, which is what is the reconstructed results verified against? I think this was covered during the webinar briefly. Over to you, Rashmi.
Okay. Can you please repeat that question, Pradeep?
What is the reconstructed results verified against?
Okay. The reconstructed results was verified with the actual optical data and the reconstructed data. As in, it's more of a regression problem that we are trying to solve, where you have an input data as your SAR data and the reconstructed data is your optical data. So that's your predicted value. So when you compare that with the actual optical data, that's where our reconstruction comparison comes into picture. Along with when we say comparison and the utility of what we talk about the reconstructed data, that's where we built up some use cases. As in what you generally do on the original optical data, we try to do the same thing in deriving the analytics, like your crop classification on a single date image, your crop classification on the multiple date image. That way, and not just paddy, we also showed you the different utility in terms of identifying the pulses, identifying the temporal pattern in the pulses that you usually see during the growing season. As in at the start of the season, you are not able to identify the complete crop. When the crop goes to certain vegetative state, that's where you are able to identify those signatures. So that way, in the presentation we covered, there is a slight difference in the data as well. So that shows the temporal integrity of the data as well.
Thanks, Rashmit. So the next question is from Sayan Mukhopadhyay, which is about the method which has been used for reconstructing the images, the Sentinel-1 images to Sentinel-2 images.
Sanjita, you want to take that question?
Yeah. So to briefly or overview kind of a answer for that would be, we have used the generative network, generative adversarial network in a complex variation of that, let's say, in order to reconstruct the Sentinel-2 data bands from Sentinel-1 data. So it's a GAN-based complex.
Thanks, Sanjita. So we'll move on to the next question, which I guess I can only take. This is from Jatin Pandya. Have you tried the SAR data from Capella? So Kapila space, no, we haven't tried that. It's a commercial data, also high resolution data. We'll be happy to do that if you are from Kapila. And, you can reach out to us on the email ID which was mentioned at the end of the presentation. We'll be happy to do that. I think collaborate with companies like ISI and Kapila space to make specific services of image reconstruction from their SAR satellites. So we move on to the next question, which is, can we share a recording of this session? Yes, it would be available on our YouTube channel in a while. Google SatSure YouTube, and you will be able to find that. Also, the same link would be provided to all the attendees over email. Then there is a question by Mr. Manish Dwivedi. What reference data was used for accuracy assessment? Rashmit, could you take that, please?
So the accuracy assessment, as I said, in terms of the spatial feature that was reconstructed was your actual data, actual optical data, as Sanjuta showed on the presentation, where we compared the data where there was no cloud cover as such, because that's the hard truth that right now we have when we compared our spatial data. And we did the comparison not just on the indices, by the way, it's also band by band comparison that we did, as in each band, how the spatial feature looks like and what's the corresponding error band that we are getting in that 5% interval. So that's one type of accuracy assessment. Other accuracy assessment that we did was based on the GT point that we have collected working for last 3 years, as in wherever we have identified the crops, we were able to validate that information using the GT point that we have collected at our end. That's one. That will just give you the precision. But when it comes to the recall of that number, we compared that with the government estimate, which was published on the government website. So the crop area that we have identified in a region, we were able to kind of somewhat map with the your actual government given data, I would say. And there was a slight difference as well, because even though it's a reconstructed image, but as well as the same error you will also get using the original data as well. So that's where there was a slight deviation of like 5 to 10% in the estimate that we were able to identify using the reconstructed data.
Thanks, Rashmit. So we'll go on to the next question. This is from, just let me see the name, please. Okay, so this is from Mr. Preetham Meshram, which is the question is have you validated reconstructed Ndvi data with other satellite Ndvi?
No, we have not actually. See, when we derive an Ndvi data from one satellite to another, there's always a sensor issue and the saturation issue when it comes to the Ndvi profile that you what you get. So for example, if you look at the Landsat profile of Ndvi, the saturation values are way less compared to Sentinel-2 data. So we were not able to do that comparison because our model does not take any other data set, as in we are trying to map the sensor data which we get from Sentinel-2 itself.
Thanks, Rashmit. There is also another question by Ithani Venkatesh, where he is asking about the 5-day revisit part, meaning where the question specifically is that Sentinel-1 data beyond the European countries, are they available in 5-day temporal resolution, or are we using some method to bring down the revisit to less than 5 days?
See, that's a good question actually. Using the current approach that we have in Cygnus is we are reconstructing SAR data to, when I say reconstructing, we are reconstructing using SAR data. SAR data has its own repeativity, similar to Sentinel-2 data also has its own repeativity. So when you club everything together, that's where you are able to identify the gaps between the two set of data set in the optical. That's where that will be filled by your Sentinel-1 data, Sentinel reconstructed data. That's one part. But in the phase 2, when I say we are able to reduce, we'll be able to reduce the repeativity, that's where we are going to introduce the other data set that we talk about is your Landsat. That's where when you combine everything together, that's where you will be able to almost reduce that repeativity by 5 days.
Thank you, Rashmit, again for taking that question. So the next one is by Prasad MSR, where he asks that the estimated area is compared to the published Government of India data. How confident are we with the Government of India published data on area or productivity for a comparison? I'll take that question myself. I think there is no confidence in the productivity data, but in terms of the area data, the government's estimates, which usually come quite late, like towards the end of the season, the numbers that they publish are usually the most closest to actual. And one of the reasons that we took Telangana, as a state for validation is because the integrity of the data collection method is very high. We have been working with the state for some time, and that's where we can vouch for, especially because there is a lot of homogeneity in Telangana. So you have the paddy, the cotton, like huge swaths of it. So it is the outputs by given by the government are very, very close to the actual ones. So with that, we will move on to the next question. Okay, which is, do you apply the model to Sentinel-2 data or Sentinel-1 data? So it is one data where we reconstruct the radar data into an optical and multispectral data set. So this is from Arjun. And then there is also a question from Sayan, where he's asking about, are we also using HLS data? So just for everyone's sake, HLS harmonized Landsat Sentinel data set. So yes, no, we are not using it. We have actually generated it. So HLS data, Sayan, for India is available only for a few places, I think Odisha and others. So we have generated the HLS data across India. And when Sanjuta mentioned phase 2 of SatSure Cygnus, so both the reconstructed data and the India HLS data will be available through Sparta. Then, yeah, there is a question by Jatin. I like you, Jatin. You ask all the good questions. Huh? Is your method tried and tested on all varieties and types of terrain and geographic regions of the world? Great question. I'll ask Rashmit to kindly answer.
Yes, Jatin. When we like in our model, we tried for multiple districts. When we say we did extensive testing as such, that's where the training data comprises of some of the districts in North India, some of the districts in Southern India, some of the districts from Maharashtra, some of the districts from Odisha, Chhattisgarh, that way. So it has a good distribution as such. So we did our testing and we were able to get the same accuracy level that we just mentioned in the presentation as well. In the 5% band, this much amount of percentage pixels are lying closer to 0% of error. But coming to the completely different geography as such, that's where the model will have to be exposed, and that's where we'll have to do a bit of tweaking to the model. Okay, but as such, there should not be, our assumption is that as such, there should not be much change in the accuracy level as well.
Thanks, Rashmit. Thanks for your answer. So we'll move to the next one, which is from a person called Bharat. The question is, removing clouds also removes the below objects in cloud edges. So this software removes cloud only, or does it remove the cloud edges or shadow as well? Rashmit and Sanjuta?
No, it doesn't remove as such. As in, like, see, we are like, as you can see in the presentation as well, what we showcase the data set. We are able to actually reconstruct the data, which is an actual representation of the region as such, and that's been dictated by the corresponding SAR data. Right, so we are able to keep the spatial and temporal integrity of the features which are lying under the cloud cover.
Great. So we'll move to the next question, which is from Parmod Mehra. Have you checked your model with the date when the cloud-free optical data was available? I think yes, we have. Rashmit, why don't you answer that?
Yes, we did. We checked the data with, see, when we did our validation, it's not just about what we are doing using the cloud cover and reconstructing the data underlying the cloud cover. So the one of the validation that we did extensively on the actual data which is available, which is completely cloud free, and the reconstructed data that's been given by the model. And we did that comparison as such. So we did the testing and we were able to get that same bracket number that we just showed, 80 to 85%.
Thanks, Rashmit. So the next question is by Abhishek, who asks whether Cygnus is an improvement over existing offering, or is it focusing on a different set of use cases? I'll take that question actually. So Cygnus is not an improvement, it is a disruption over existing offerings. So the existing offerings is you have cloud and optical data, remove the cloud and then process the images. And if you are using synthetic aperture radar data and you are looking at let's say crop classification, it's quite easy to do the classification for water intensive crops like rice and jute, but the scalability of doing crop classification on the synthetic aperture radar data for crops like soybean, cotton, etc. is not very well researched today globally, as well as not well understood as well, because responses are very different, especially when you are dealing with Sentinel-1's publicly available two polarization data, the VV and VH. So what SatSure Cygnus is offering to all the analysts who are working in different organizations where the requirement is to identify the areas under crop is that you wherever you have the cloudy dates, you are missing a temporal scene, right, within your when you are doing a phenology mapping to do the crop classification. So you can simply replace that cloudy data with a reconstructed optical data. Today, one of the most popularly used methods is a combination of optical and SAR to do this kind of classification. But again, those can be time consuming if you are using data fusion techniques. So all in all, we have ourselves at SatSure done this level of I would say very operational validation, where we gave the reconstructed scenes to our remote sensing team and asked them to classify the crops, and using the reconstructed scene they got the same area, just with 1% variation to what they got from the original optical temporal stack of data. So if analysts are able to interpret the clusters when you are looking at temporal stack, I believe this in itself changes the way in which we are doing vegetation monitoring using satellite data, especially in cloudy conditions, where it overcomes the of handling SAR data for non-paddy crops. So the next question is on location visit frequency, which was highlighted for older solutions. What is the expected baseline for location revisit for different use cases, especially agriculture, where the older satellite revisit frequency is sufficient or not? Okay, so in phase 2, as was explained by Sanjutha, we will be also adding the HLS data sets. HLS is the Harmonized Landsat Sentinel data set. So when we bring together Sentinel-2, Sentinel-1 reconstruct Landsat 8 data sets, then we can achieve, especially when there is no cloud cover, let's say the winter times, up to 3 days of repeativity in most parts of the world. But when you have continuous cloud cover, then the maximum that will go up to is 10 days. So I think there was a question about how it is coming to 5 days. So 5 days is a place which is a surety we are providing on providing the service, the Cygnus service, with the maximum being 10 days when it is continuously cloudy for, let's say, 4 weeks or so, and the best is the 3 days repeativity. And the good part of it having to use any commercial data at all. We are simply running AI models on our platform and generating this kind of high frequency data. So definitely the older satellites where you call is a virtual constellation is actually not a virtual constellation. It's a mishmash of different data sets, different sensors. What we are doing is bringing all to a single configuration, a single APL. So yes, that is our innovation on the service. I'm just looking at the questions keep coming. I'm glad our team finished the presentation in 20 minutes for more questions. So the questions from Arjun M. Is it possible to get detailed report of accuracy? So the detailed report of accuracy will be provided to each and every user who is paying for SatSure Cygnus service. And this is a continuously learning model on the platform. So if there is a let's say we will provide SLA of 90% accuracy, and if the accuracy is not meeting 90%, there will be a retraining done at our end, and an image rendered the next day. So yeah, that's the scene. At the moment, we are not releasing the entire validation test reports. Reason is we have filed for a patent, and we are waiting for it to be granted to us. We'll, as soon as it is done, we will make these all results public. Okay, so I'm looking at, okay, another question has come from Santosh Reddy. Is this only applicable to crop monitoring? Do you have any plan to extend to ocean products to derive chlorophyll and SST, sea surface temperature? It's more of using Sentinel-1 and 3 in place of Sentinel-1 and 2. That's a great question. I would love if Rashmit answers.
See, right now it's basically for the crop monitoring, not just crop monitoring as well. It's also about the vegetation monitoring. When you talk about vegetation, forest, all the other features, along with the urban features as well. Coming to the ocean products, yes, we could do that, but right now there's no any plan for that particular fusing of Sentinel-1 and Sentinel-3, like what we have for Sentinel-1 and 2. But thank you for the suggestion. Actually, we'll take that into consideration while deriving our phase 2 and phase 3 plan.
Okay, so we see that there is no more questions to be answered. So if not, we would like to thank everyone for firstly a very engaging session. A lot of good questions that came to us. We are very excited to see the traction on SatSure Cygnus, and I'm sure that a lot of the things which were discussed as going to be planned will be launched soon by us. And with this, I would like to extend the thanks again to all the participants for attending our webinar. And also I would like to thank our team members, Rashmi Singh Samphani, Sanjutha, and Sarvesh Kurne. Please feel free to send your questions and requests for demo on sparta@satsure.co. You can check my colleague Sarvesh's text on the chat window. And with this, we would like to end the webinar. And thanks again, everyone, for attending. Bye-bye.
Thank you, guys. Thank you for your time. Thank you for attending the webinar. Thank you. Bye.